Alrighty, we are continuing on with discrete random variables. Today we are going to be looking at the probability distribution. All that is saying is, what's the probability of each possible outcome? Okay, so example 1, we're rolling 3 dice. And X is the number of 4s that we get. Okay, so in that case, well, none of the dice could show 4. One of the 3 die could show 4. 2 of the dice could show a 4, or all 3 of the dice have a 4. Bunco! So if you play bunco, you know what that means. If you don't, sorry. Okay, the thing is, there's different ways we could do this. So the 0, there's only one way. Failure, failure, failure. All 3 dice show a number other than a 4. But the probability of that happening, well, if a regular die has the numbers 1 through 6, the probability of not getting a 4, there are 5 different ways to do that. So 5 out of 6 on the first die times 5 out of 6 on the second die times 5 out of 6 on the third die. So the probability of getting 0 4s is 125 out of 216. Okay. Getting 1 4. Well, the first die could get a 4 and the second 2 don't. The first die doesn't, the second die does, the third die doesn't, or the first 2 dies do not get a 4 and the last die does. So success, failure, failure, well, getting a 4 is 1 out of 6, not getting a 4 is 5 out of 6, not getting a 4 is 5 out of 6, but notice there were 1, 2, 3 ways to do that, so I multiply that by 3. So multiplying that out, the probability of getting 1 4 is 75 out of 216. What if we got 2 4s? So success, success, failure, the third die does not come up a 4. Or first die does, second die doesn't, third die does. Or first die doesn't, second die does, third die does. So we have 2 4s and a number that's not a 4. So success, success, well, 1 out of 6, 1 out of 6, and then failure, 5 out of 6. But again, there's 1, 2, 3 ways to do that, so I have to multiply that by 3. So the probability of getting 2 4s is 15 out of 216. Or, since we're trying to get 4s, this is the good one, success, success, success. The first die is a 4, the second die is a 4, and the third die is a 4. So that's 1 out of 6 times 1 out of 6 times 1 out of 6, which is 1 out of 216. So this is called the probability distribution. As we could now just look at this and say, what's the probability of getting 2 4s? What's the probability of getting 1 4? Okay, but a lot of times we don't just want each individual probability. So like C, find the probability of getting at least 1 4. Well, that would be 1 4 or 2 4s or 3 4s. So we add those 3 probabilities together and we get 91 out of 216. Or this one, find the probability of getting at most 1 4. Well, that would be 0 4s or 1 4. So we add those 2 and we get 200 out of 216 or 25 out of 27. Okay. All right, so properties of a discrete probability distribution. Well, each individual probability is somewhere between 0 and 1. So the smallest probability is 0. If something cannot happen, it has a probability of 0. The largest probability is 1. If something is going to happen for sure, it has a probability of 1. And then here's something very important. The sum of the probabilities has to add up to 1. If I add these 4 numbers together, I get 216 out of 216, which equals 1. So the sum always has to add up to 1 because the largest probability is 1, and all of these together make up all possibilities. So they're always going to add up to 1. All right, so example 2 is using this information. Let Z be a random variable with the possible values 1, 2, 3, 4, or 5. The probability of Z is Z over K. So first thing is we want to solve for K. So I'm going to add up all the probabilities. So the probability of 0 is 0 over K, plus the probability of 1 is 1 over K, plus the probability of 2 is 2 over k, plus the probability of 3 is 3 over k, plus the probability of 4 is 4 over k, plus the probability of 5 is 5 over k. So that was just using this formula they gave us. But we know that added all up together, they have to equal 1. Well, they have a common denominator of k, so I add up all the numerators and I get 15 over k equals 1. Multiply both sides by k, and k equals 15. All right, so B says find the probability of z being more than 3. Well, if you look at our possible z values, the only two that are more than 3 are 4 and 5. We now know that k equals 15, so this is now z over 15. So probability of 4 is 4 over 15, plus the probability of 5 is 5 over 15, so our probability would be 9 out of 15. All right, so that is the probability distribution of a discrete random variable.